An electric DC motor consists of 500 turns of wire formed into a 20 centimeter by 10 centimeter rectangular coil. Right? The coil is in a field of 1 millitesla and a current of 4 amps flows through it. What is the maximum torque and when does the coil experience it? So to answer this question, we need to remember our equation for torque. Can you remember what it is? That's right. Torque equals NBIA cosine theta. Right? Now, if we want cosine to be a maximum, that means that we want theta to be 0, right? So we know that our coil is going to need to be parallel to the field, which means that our only options are A and C. In order to figure out the magnitude, all we have to do is substitute in N, B, I, and A. And so by doing that, we end up with an answer of 0.04 Newton meters. Question 2. A wire is placed on top of the pole of a disc magnet as shown. So we can see that the flat surface of the magnet will be either the north pole or the south pole. The wire is connected to a battery and experiences a force in the direction shown by the arrow. Right? So we either have current flowing from X to Y or from Y to X. So what are the directions of the magnetic field and the current? We have two options for the field. The field is vertically upwards or in the direction of the arrow. Now, because we know that the face of the magnet, that is, the top, is either the north pole or the south pole, we know that we can't have the field going across it in the direction of the arrow, right? So our only option is that the field is vertically upwards, right? So we might draw something like this coming out of the top of the magnet, right? There's our magnetic field. Now, in order to figure out the direction of the current, we need to use our right-hand rule, okay? So the magnetic field points upwards, and the force that the wire experiences points in that direction, which means that the current must be flowing from X to Y. So A is our correct answer. Don't forget to always use your right hand with the right-hand rule. If you're using your right hand to hold a pencil or a pen, and you use your left hand instead, you'll get the wrong answer. Question 3. An electromagnet is attached to the bottom of a light train. When a large current is passed through the electromagnet, the train slows down as a direct result of the law of conservation of energy. Now, in which one of the following devices is the law of conservation of energy applied in the same way? So what's happening when the train slows down is that the changing magnetic field passing through the wheels is causing the wheels to try and stop moving in relation to that magnetic field, right? And so they slow down. Now, in these four options, there's only one option in which something tries to keep up with a magnetic field. And that one is, of course, the induction motor. In the induction motor, instead of a stationary magnetic field, we have a rotating magnetic field. And so in order to allow conservation of energy to happen, the rotor inside the motor has to turn around at the same rate as the field. Otherwise we would get electrical energy out of nowhere. Just like we would get electrical energy out of nowhere if these wheels didn't slow down, because we would have a conductor in a changing magnetic field.